please.
Okay. Just let me know if my screen is visible.
Yeah, it's visible.
Yep, visible
Okay.
to me.
Okay. Okay, then great. Let's start. So the topic for today's session is designing and implementing .NET APIs using serverless programming model. So moving on, just something about me. I primarily work as a .NET developer. I'm a cloud enthusiast, and you can connect with me after the session over these places. I'm quite active on Twitter and LinkedIn, so we can connect there if we have any queries which I can't solve in the session today. Okay, so moving on to the agenda for the session. So we'll start with discussing what is API, then how can we make one. Then we'll just discuss a small bit about evolution of the application hosting platform. This will be with respect to the how we came into to the serverless thing, the serverless architecture as a whole. Then we'll discuss what is serverless, because the whole session is about that. So post that, we'll discuss about Azure Functions, which is a serverless offering offered by Microsoft Azure. So we'll be using this to make serverless APIs. Next, we have an interesting problem statement. We'll try to solve this using Azure Functions. So first, we'll have a look at an web API, .NET Web API, which I had made to solve this particular problem statement. Then we'll try to execute the same thing using the serverless approach with the help of Azure Functions. And finally, we'll publish them in Azure, and we can test them over in Postman. Okay. So what is an API? Would anyone like to help me out with that? What is an API? Feel free to share your thoughts.
Hello.
Yes.
Yeah. API would be its full form would be application programming interface, something that a client, as you can see in your slide here, a client can connect to it, and the API does whatever tasks it needs to do, whether it's fetching database, data from the database, or processing that data and sending it back to the client. And it could be either a
That's good enough.
Yeah.
Okay. Okay. So basically, API is nothing but a common set of methods of communication between multiple, software components or a client and a server. For our example, by taking the web as an example over here, just imagine you're trying to book a railway ticket. So there are multiple sites which offer you to book a ticket. There's one from IRCTC. They maintain the whole thing. So it's pretty legitimate that okay, you can book a ticket from this site. It will be reflected in the database and everything. But how is Make My Trip or in Go IBBO, so you can book tickets? How are these people able to book tickets for you for IRCTC? So what happens inside is that IRCTC. Yes.
Yes, sorry to interrupt. Your voice is in between. It's breaking for me.
Is it the case with everyone?
Yes, there are some breaks.
No, I guess it's fine for me. I guess maybe your internet connections are a little bit slow. I'm able to hear it very clear.
It's a bit choppy, but it's
Okay.
Understandable.
Okay. I'll just check. Sorry, I'll just check my table. Okay. Is my audio audible well now? Still is breaking.
It's choppy.
Is it breaking still?
Yeah, a bit, but you can go ahead.
Yeah, for me it's okay, man.
Okay. Okay. Actually, it's been raining outside, so maybe there is some network issue. But I'll try my best. If anywhere you miss my voice somewhere, just let me know. I'll repeat it again. Okay.
Cool.
Sounds good.
Yeah.
Okay. Okay. So we were about how my Go IBBO are able to book a ticket for IRCTC. Then IRCTC from them some of their open source APIs which they can use in their application. Using like whether seats are available or not. If seats are available, then it's okay. So the
Hello.
same can be reflected in the DB and the.
Yeah, sorry, your
Yes.
voice is getting a lot choppy right now. It's not comprehensible. Like, can you try reconnecting
Okay,
maybe?
just okay. Give me a moment. Just give me a moment.
Okay, we see a few hand raises. You people can unmute yourself.
No, we just raised it to say the audio was breaking. That's it.
Yeah,
Yeah, I
Okay.
think the others were all audible
Is it
properly. Go ahead.
okay? We can go ahead then, right? We can go ahead, right? Paras, you there?
it's me, Kunal.
Hello?
Yeah, like it's better now.
Okay. Just try to check. Okay. Okay, we can continue then. I'm really sorry for the internet issue. Please bear with me. Okay. So how can we make an API? So we can make APIs, using multiple ways. In .NET, we have WCF, we have web APIs. If you're using, some older technologies, you have web services to make one. You can make web APIs using Django and Flask in Python. Same with Express.js in Node.js, and Spring in Java. So this is all about the APIs. These are just common set of methods which we normally use to communicate, between our multiple servers, or what we can say, multiple applications. So let's discuss something about the evolution of application hosting platform. So traditionally, what used to happen is that, let's take an analogy, like we are staying in a pre or post COVID time in which you move around some places. Suppose I'm currently based in Bhubaneswar, so I need to come to Bangalore. So if I come to Bangalore, I need a place to stay, right? So I have multiple options to take. One thing is I can buy a mansion and stay over there, right? For this, I need to have a lot of money, but just for this particular situation, let's think that okay, we have this much, buy a mansion. It's more similar to an on-prem setup. You buy the servers, you have the storage devices, you have all the RAMs and everything set up beforehand. You have people to manage everything over there. So this was how things used to happen earlier, in the initial days. Even still, many organizations actually have that. So the problem is there is a lot of upfront cost that is associated with this particular thing. You need to set up everything. And suppose like the Big Billion Day sales are going on. So if you are expecting a spike in your network traffic, you need to install a lot many servers. But post that, what is going to happen? These servers are going to lie dormant. These are just going to add up as additional cost for you. Right? Making sense? Okay. After that, we got a bit smart. We thought that, okay, why should we buy a mansion? We can we can just rent one. It wouldn't cost us that much, and after maybe 10 days or 1 month, we can give up the lease and go back. For me, I'll go back to Bhubaneswar, instead of staying in Bangalore. So I reduce my cost over there. Now I don't need to maintain the whole storage device. I need not buy everything. I can just take it on a lease and use it. So that's more of an IaaS approach. That's more like a VM that you take, where you're not bothered about, actually, or the hypervisor thing. You don't worry about, buying out servers, buying out storage. You have the option of auto scale. You need not even check about the availability of the servers, whether they are available on the market or not. So you can just rent it out from your cloud vendor. But still, if your application is not being utilized that much as you have allocated the memory for it, still the money is being used, not it's not effectively used in a way, you can say. So then came PaaS. Okay, why do we need a mansion? I'm just a single guy, I can stay in a flat, right? So why should I take the whole thing? I don't need a mansion just for a single guy. I can go for a simple flat. So this is moreover a PaaS. In this, what happens is that you need not even bother about the storage right now. You just need to maintain your traffic. You just need to maintain about your vertical scaling and the horizontal scaling part. You just need to have to what we say, you need to fix like how much server you actually need, how much allocation do you actually need. That's all. You can also have an auto scaling option which you can turn on to auto scale whenever the traffic is going more. Okay, everything is well and good till now, but what if my application is seldom used? There's one particular feature in my application which is never used, but still it occupies space, and I pay money for that. Why should I pay money for something which is not being used or rarely used? So there comes serverless. Now we have discussed about buying a mansion, renting a mansion, taking a small flat. Now there's OYO. You can just book a room in a hotel and stay there and just pay for the time you're actually gonna stay there and use the resources. Why should you pay more, right? So it's more over like serverless allows you to actually pay money for whatever the time you actually use those resources. You don't need to pay anything for your idle time. Makes sense? Um, can anybody confirm that I'm audible till now?
The last sentence like broke up, but before that it was fine.
Okay. So renting a room in OYO is moreover like you don't even need to pay or take a lease, sign a bond, anything for a flat or an apartment or a property. You just go there, stay in the hotel for the number of days you want, and post that you can go out completely hassle free. So that's what serverless is in the application hosting platform. You only pay for the amount of execution time you or resource. You consume the resource that you pay, nothing else. No idle, you won't be having idle time of resources which you are actually provisioned. Okay, so moving on, let's talk briefly about serverless. So serverless, the topic of the session was moreover like implementing the serverless programming model. So I'd like to tell serverless is moreover like an architecture, right? We have MVC, right? So in a similar way, serverless is an architecture. It's moreover a thing in which you have an abstraction of infrastructure. In layman's terms, serverless is just the abstraction of infrastructure. Okay, it allows developers to focus on the business projects.
Hello, Mr. Ashirwad.
Yeah, could you please repeat again the last sentence? I couldn't hear you properly.
Which one? For serverless? Or in the before slide?
Mr. Ashirwad, we are hearing robotic voice and you're not trying to fix it. I
Okay,
don't
just
know there are too many people on your router.
no. I am just a single person over here.
Okay, you got a bad internet connection or what's the
Actually it's actually raining outside, so maybe my okay. Just give me a moment. I'll try to connect with the
raining
network
will
then.
not
Just give me a
bring
moment.
the internet bandwidth lower. Okay, so it is the issue with the bandwidth.
Okay.
You're downloading
Just
some
give me a
movie
moment.
or something. You have put down some download somewhere in the browser.
No, nothing of that. Just give me a moment. I'll try to connect to a different network. Please be with me. Hello. Hello, everyone. I'm really sorry. Is it audible well now?
Yeah,
Hello?
Still a bit choppy.
I'm sorry. I'm sorry for this. Is it audible well, right? So we can
Yeah,
continue
it's
with
good.
it. Okay, that's great. Okay, so we were on serverless. What is serverless? So serverless is nothing but the
Ashirwad,
abstraction of infrastructure management. Yes,
Ashirwad, can you hear?
yes.
Yeah. So I have a recommendation. If you will speak slowly, I think the breaking of voice will be somehow rectified. So if you can speak slowly, it will be good.
Okay.
Yeah.
Okay, I'll speak slowly. Okay, so serverless computing is the abstraction of infrastructure management. So there are multiple features that a serverless architecture normally has. So few of them are: a serverless application is stateless, just like in REST API. These are event driven. These are only run whenever a particular event is being fired. Microbilling is more like you only pay for the number of seconds your resource actually executes. And the third is, which we had discussed before, abstraction of server or your infrastructure. So Microsoft Azure has a lot of serverless offerings, like there's Azure SQL, which is this serverless offering for DB, and there's Azure Function, which we are going to use to make an API. Then there's logic apps. Suppose you're not from a coding background, but you want to build application. You're more on the what we say the business side. So you can use the GUI panels to drag and drop and make applications using logic apps. And there's Event Grid. So primarily we'll be discussing more about Azure Functions in this particular session. So just like the serverless architecture, Azure Function overlaps a lot many features with the serverless architecture. First is stateless. Second is event driven. These are normally triggered whenever a particular event is triggered. Like we have blocked, there are multiple types of triggers which actually fire an Azure function. One can be an HTTP trigger, which we are going to use today. There's others, like there's a blob storage, there's a message queue. Whenever a new message gets in your message queue, your particular event happens and your function runs. There are also triggers which are associated with Cosmos DBs and many more. Next, abstraction of server. You need not worry about the servers here at all. This is a function as a service offering. There are multiple other function as a service offerings available with other cloud vendors, like this OpenWhisk for Apache. There's Google, Cloud Function in GCP, even this Cloud Function which are actually based upon OpenWhisk which are available in IBM Cloud. There's AWS Lambda. So this is microbilling. You only pay for the execution time of your resource, not more than that. So how can we make one? There are multiple ways in which you can make an Azure function. One is going through the Azure Portal. The next is through the Azure CLI. You can make one using Visual Studio locally, using Visual Studio Code too. Even you can make it with any other, any other IDEs by using the CLI, the core runtime tool. Okay, so we'll go with the demo, like how to make one using the Azure Portal for the time being. Okay, can somebody confirm that I am audible? There's no network issue.
Yeah.
Yes,
Yes,
Yes.
it's very fine now.
yes, it is. You are
Okay. Okay, great. So let's go with the demo. Okay. I'm logging into my Azure subscription. Okay, so for doing this, you need an Azure subscription. That is the prerequisite, you can say. So let's log into my Azure portal. Let's create a resource. Okay, to make an Azure function, we need to create a function app. You can search it over there, or it was just there. Okay. So we'll select a function app, then we'll create. Okay. Longer than usual. Okay, by the time it comes, I can show you one which I made already. Okay. Let's try to reload it. Okay. Okay, guys, since it's taking a lot of time, let's not waste more time. Let's make one locally. Later on, we can check one using that. Sounds good? Is it okay with everyone?
Yeah.
Okay. Okay. So let's make one locally. Make it locally. I'm using Visual Studio 2019 Community Edition. So for this, you need to install an SDK. That is a Azure Development SDK. You need to install while you're installing Visual Studio 2019. So let's create one. Okay. I have this option directly available because this was one of the recent project template which I used. But for you, you can go over here to Cloud, then go and click on Azure Functions. Let's click Next. Give a function a name. Maybe Func app, MSFT reactor. Okay, let's create it. Okay, so I was telling you about multiple triggers, which our Azure functions are event-driven. So basically, there are multiple events which can actually trigger your function. So these are which can trigger an Azure function. You can have a timer-based trigger, and run your Azure function on a particular times. Like you want to clean your database every 30 minutes or every 30 minutes, you can use a timer. Suppose you have an event head up with your services, you want to fire an Azure function, you can do that. Same with queue trigger, and there's everything. Even when you upload a file to your blob storage, you can fire a function to do something. Like suppose you uploaded a file, you want to reduce the resolution, or else you can use any cognitive service to actually analyze that image and share the information via email using SendGrid, or else you can store it in a DB. All the thing is possible using Azure Functions. So we'll be working with the HTTP trigger over here. Okay, so we need a storage emulator over here. It's somewhat similar to a storage account. So what it does is that it stores all your logging information. Any of the storage concern that your Azure function has will be taken out with the storage emulator. This will take care of all these issues. So the next is the authorization level. So there's function, anonymous, and admin. So we'll be using anonymous because we don't want any authentication over here, or else you're required to give a key to use this particular thing. Locally, you don't need it, but whenever you publish it to your function app in Azure, you'll be having an key which you need to pass as a query string, or else in your body to actually use your Azure function. If you don't have that, you won't have access to use this. Let's create it. Okay, to test any of the API that we are making over here, we are gonna use Postman. Okay, it's loading. Okay, so it generated a default function named function1. So this is going to be our function name. We can change it, and you can see over here, this is the attribute that's available over here. You just give it a time, it will remove all these errors. It normally comes when you create a project, but after you build it, it's gone, as you can see. So you can change the authorization level over here, which we don't want actually to change. Let's keep it anonymous. You can also mention the type of request that this particular function can take. Like, can it take a post, or can it take it get? For the time being, we can only keep it as get. Okay. Okay, great. So this is a simple Azure function which displays your name. You pass your name as a query string, and it picks it up and displays the name. So let's run it and check whether it works or not. Okay, guys, my audio is audible clearly, right? Yes, sir.
Occasional choppiness,
Yes.
but mostly okay.
Okay. Okay. Since this is the first time we are building this one, so it's taking a bit time, but normally, as you go on and use this, it won't take this much time. Now I started the Azure Core Function tool, this is basically the runtime in which, your Azure function runs. We're using the, function runtime version 3. There are multiple others like 1, 2, and 3. Okay, so you can see over here that we have only one single function here, or in a way you can say we have one particular API which we can use. So let's go ahead and test it now, Postman. Okay, let's create a new request. Let's go there to the URL, mention get, give it a query string name. So I'm giving my name over here, Ashirwad. See, I got the response as hello Ashirwad, this is distributed function executed successfully. Now, you might be
Ashirwad, your video is lagging actually. It's still stuck at the request name. Am I the only one facing, or how about others?
Yeah, I'm also facing the same.
Yeah, we are facing the same.
okay, still the same issue. Okay, where is my screen stuck now? Is in the Postman or is still with the Visual Studio?
Yeah, it's visible now. But what I'm saying is there is a few seconds of lag between when you switch windows in your from your teams actually. So that's what I meant to say.
Okay. I'll wait for a second. Then.
Yeah, just wait for 2 seconds and then continue.
Okay, great.
Now it's good. Now we can see
so,
your.
Okay. So basically, this is Postman. How Postman looks. I mentioned a get request. The function was taking get. Passed in a query over here. My name equals Ashirwad. Then I sent in a request, and it got this as a response. Basically, what we say, basically an API, a RESTful API. What does is that it takes a request, does the work whatever you need it to, then gives you back a response. So I got the response over here. This was my response code 200 OK, which means it executed successfully. Now, if you wanted to check the debugger, like can we debug our Azure functions? We can keep a breakpoint over here, pass a request again. I'm switching back to Postman, so let's wait a second. We are there in Postman, right?
Yes.
Okay, I'm sending a request. Now you can see we have a hit on in our breakpoint. Now we can just click F10 and go by and as we normally do with our .NET applications. Let's check whether we know the name. Yes, we got it. So we can go through and just loop around and check everything around. Okay, so this was how we make a simple Azure function locally and test it using Postman and debug it. Okay, so let's move on to the presentation. Okay, so we have a problem statement. Everyone is able to see the problem statement, right?
Yeah.
Okay, I'm reading it out. You're an organization named India Inc. And of late, your organization has not been able to retain many of its existing customers. To understand this, you're sharing a feedback form with your customers to share their experience with your organization. Now, the management wants to receive all the negative feedback said by the customer, address these concerns and work on them. So basically, you have a name of people who are your customers, so it's pretty easy for your organization to do feedback. But the problem is, there's so you just want to focus yourself on some having trouble using tools. So you want to work on that. You want to improve their experience. So problem statement is more or like you send the feedback, you all the negative feedbacks and share it with your management. So how can we use, how can we make an API to, to help us solve this particular problem? So I'm using Web API, which I'm going to share with you, and then we'll look at rework. How can we convert the same Web API into an Azure function? An HTTP Azure function to act as an serverless API. Okay, so this is the API. As you can see, this is a normal. This is how the normal Web API normally looks. Is it visible? All of us are on the same screen in Visual Studio, right?
Yep.
The screen is lagging.
Yeah.
Okay. Okay. So I have control over here to list out all the feedback, all the HTTP methods for this particular feedback mechanism that we have. So I have this particular thing submit feedback over here. So in this submit feedback, what happens is that it's a post request. Whenever we submit a form, submit data is a post normally. So this is information to a particular API to take. Once we get that particular details, get info, which is a feedback object. What's feedback object? This is a model in which I want to store and work. Sorry, anybody was saying anything?
Yeah, it's getting choppy.
Okay. Okay. I'll say again. I'll say again. Okay. So we are in the feedback controller right now. This contains all the methods we have to work on this particular problem statement. So we are primarily work on the feedback method, the API, which takes a feedback model has these many properties: name, email, feedback on the feedback that the customer gives. Then we have a feedback rating. So the feedback rating is analyzed using the text analytics cognitive service of Microsoft Azure to find out the sentiment of the feedback. We classify it as positive and negative, and depending on that, we perform our operations and the product on which we actually give our feedback. So let's run it and use the debugger to go through the flow. That would be more helpful, right? Okay, I started it. Should start in a minute. Okay, I started. Let's do some feedback over here. Okay. So this is what the route is. I added these things already in the body. The ID, the name, the email, the feedback on the this was really bad.
Your screen is still lagging. Just hold on for a second.
Okay, sure.
Yeah, we are still in Visual Studio actually.
Okay, okay. Just wait for a minute.
Yeah, it's good now.
Okay, great. So I have put my what we say, the address, you can say, API slash feedback is the controller. So then we have this API method submit feedback. So we are going to work with that. This is our feedback to work on. So this is a post one. So we have mentioned it post over here. Then we are passing in all the details that we want to pass in a body. So you can pass it as a parameter over here, this, or else as a query string, or else in the body. I'm passing it in the body. Select a JSON format to pass it up. Let's make it and send it. Okay, now we are over in the debugger. Click and go deeper. Then check. This logic has only these few things. You can see in the object we got all the details that we had passed in our body, request body. Right? Everyone can see the visual screen, right?
No,
Hello?
We are
Sorry,
still.
your voice was a bit. Okay. Okay, just let me know when we are in Visual Studio.
Yeah, we are in Visual
Okay,
Studio.
are we there? Okay, great. So I did the next step while screen was lagging. So we're in business right now. As you business has three things, you know. One acts to just find the sentiment of our feedback, whether it is positive or negative. The other is to send the email, and the third is to insert the feedback in our DB. Right? You want to store those feedbacks so that you can analyze it later. So when we click over here, we can just jump in to check what other things we have inside over there. Okay, so this is our feedback analyzer. You can see I have given my API key and the URL over here. This is just a normal method, that is required to use the text analytics APIs. We are just consuming an API of the cognitive services that are available on Azure. So we are trying to find out the sentiment over here. Okay, just the feedback over here. This was a really bad order which we gave. Okay, now it analyzes the whole thing. It's gonna send a request to press the whole details. It's also an API which are consuming inside our API. It's an interesting thing. Okay, so now we got our sentiment. We can just check it over here. The sentiment is negative. Okay, so since negative, we need to send two mails. One to the customer that we acknowledge their feedback, and the second to the management team. Okay, there's a negative feedback, and you need to know about it. Right. So let's get back to the business. Now we are back in the business. We'll go down to the email part. Let's see how the email function works. So I'm using sendgrid over here. This is my API key. We normally, we shouldn't, put our API key directly over here. We should keep it in our environment variables. Things or in the JSON file, also JSON file. But just for the ease, I put it over here. Okay, you can see this over here. I have a condition. If feedback rating is negative, if the sentiment was discovered in our particular feedback negative, we need to send two mails, one to the management guys and the other to our customer.
We are still in the submit feedback method actually. Yeah, now we have reached that method. Yeah, sorry. Even from switching tabs, there are lags as well. Sorry about that.
Okay, okay. I'm sorry.
Yeah, you can just repeat it once.
Okay. Wait for a few seconds. Somebody can make confirmation, then I'll again jump into the next step. Okay.
Okay.
Okay. So this. Okay. So this is the condition. So I have two methods over here. You can see one is to send mail to client. The other is send mail to management. The definitions over here are very much similar. There's no change over there. You can see I'm creating a client. Again, I'm using an API over here. I'm using a lot of APIs inside my API to do the thing. So I'm calling the send grid to send in my email. So from the set from, I'm saying from whom I'm sending, who is sending this mail. Like suppose Paris is sending everyone the invites for attending today's session or any other session on Microsoft Reactor. So here Paris mail would go. Second, to whom you want to send the mail. This mail is to the customer. The customer shared his mail while passing, while sending a request to our API. He said his email in the body. So this is my email which I shared in the body, and my name. So this is and this is going to be this subject which is pass and the message. Message over here. Convenience will try to improvise to make better experience for you. So this is what it is. And for the management people, I want them to see what the actual feedback was. So I'm giving them the feedback with the customer actually said. I'm not sharing any other information regarding the client. Because this can create bias, cannot create, there's a lot of things. Even there are some concerns regarding customer's data.
Just one query. What exactly is a SendGrid client?
SendGrid is basically a service which allows you to send emails. It's just like a API which you can call, send emails. Just like Tulio does for sending SMS, this does for sending emails.
So why we are not using an SMTP client here? Why are you preferring a SendGrid client?
Because this takes away all. Actually, the thing is more like opening up the port. there are some security concerns, you need to address, but SendGrid does all these things for you, and it offers me 25,000 Azure subscription. So I prefer to use it.
Okay.
No specific reasons actually. It's just this my priority, I prioritize it better. Okay, so these are the two methods. So okay, let's go forward with that. Okay, one request gone. Let's go for the second one, and it's done. And we'll come back to the body, to our actual business. Then we will insert this particular thing in our DB. I'm using AD.NET over here instead of you can use here. Normally not, but for this I have used AD over here. You can just go in. I'm opening a connection over here. This is thing. I'm passing. I'm adding all the parameters over here.
Ashirwad, slow.
Oh, okay. I'm sorry. I'm
Still
sorry.
in feedbackbusiness.cs.
Okay.
I know it's irritating, but can't help. Yeah.
Okay.
Now we are in your
I'm
data.
sorry.
Yeah.
Okay. So I have been my connection string over here for my DB, which I have actually, which is Azure SQL DB, which I have provisioned before this session. So right now we don't have any session, any record after Aman here, which I had updated, a long time back, probably in the afternoon while testing the whole thing. So let's add on all the parameters which we had passed in our body. And now we are inserting the record. And we have inserted it right now. We can see the number of rows inserted. Now the insertion operation is done. Okay. Let's wait a while. All are back in the same screen, right? In the business, we are all in the business. Okay. Okay. So we got we inserted it. Now we are returning the feedback. You can check feedback over here. Am I audible?
Yes, you are.
Yeah, you are audible,
Hello?
but your voice is interrupting. Yeah, it's breaking.
Okay. Is it breaking or is it clear right now?
It's still a bit choppy.
Okay. So you can see the feedback rate. We didn't give any feedback rating while we passed all the data in the body. We didn't give anything as feedback ratings, but we got the feedback rating over here as negative, which we got it from our feedback analyzer class. Now we are gonna return it. Return the feedback object. Just click continue to go back to Postman and see the response. As you can see, we got back the response over here. Now let's check whether this, whether we got a mail or not. Since I have added myself as a management guy over here, so I should get mail regarding this. Let's refresh my inbox. Let's check. Okay. Is my inbox visible to everyone? Or the screen is still in Visual Studio?
Not yet. Loading.
Yeah, it's visible.
Yeah.
Okay, I'll wait. Okay, as you can see, I got a mail from myself. So you can see I got the feedback which the user actually gave. This was a really bad product. Though there are not much inside, but some customers can, give detailed feedbacks. You can see it was sent from my other email address, and it got to me. Okay. So now our task is to replicate the same thing using Azure Functions. So we had a running instance of the previous function, which we, the hello world Azure function which we're running. Let's stop it and look at the solution. Okay. Before that, let's look at the project structure of the API. Let's stop the API. And wait, does someone confirm me whether they're on the API's Visual Studio? All of us are on the Visual Studio, right?
Yeah.
Okay. You can see the structure over here. I have a business. I have a Dell data access layer. I have a model. I have my API, and I have the utility classes. So we can go with the same approach over here with Azure Functions. Suppose you have already built an API. You want to go to take the serverless approach. You want to rewrite the APIs. It's very simple. Actually, you just need to make the modifications only in your controller part. So let's see. Let's see the serverless version of the same API. In the version of API in the serverless way using Azure Functions. You can see the project structure over here is more or less the same. We have the BL, we have the data access, we have the model. This is the function app, which was which was the API in the case of a normal web API project. And we have the utilities, all the same things, nothing changed apart from just this particular project. The MS Reactor function app. This is the function app. Okay, there are no other changes over here. So I'll just go through these classes. The email helper is the same as it was in the case of the API. Nothing. I haven't changed anything over here. You can see same two same two methods. And management, the same business condition, how the email should go. Same API, same thing. Same with the feedback analyzer. I have defined the same thing as it is. It was there. No more changes. Though I have added a few nugget packages over here, which I would like to show it to you people, which you can actually use it. If you want to use the same thing, one is you need to install the SendGrid nugget package and the Azure.ai.text analytics package to actually do the sentiment analysis part. So these are the two things which you would actually need. I just showed how to provision the whole thing, but it's taking a longer time in the Azure portal. So I'm just showing you which packages you need to install, nugget packages you need to install to avail all these functionalities. Okay. So this is done. The utility part is done. We'll look at the model. We have the same models over here, the same feedback class, the same product class. Go to the DAL layer. The same. Nothing has changed over here. It's all the same. The only difference which would come is that I'm able to create an interface because the Azure function by default is a static method and you cannot implement interface directly in a static class. So over here, this is the only difference. And what we in controllers here, utility, email side, and the previous API, same SQL Server, and return feedback as a response. Now, as we have already gone through all those packages, which was already there in web, here the actual content. Like what part did we change in the controllers that to rewrite in Azure function? As you have already seen how to create a simple Azure function has to trigger. The same thing. Just I had renamed it as submit feedback. The function name. I've given only post. You can only have post method. You can also define a custom routing. As in our case, we had like API slash feedback controllers slash submit feedback. We can also mention some, specify something like this. Like if I change it and write it as test demo, then our API name would be test demo instead of submit feedback. But by default, the name of our API would be the name of our function, the name of our function or the function name, which we have mentioned in the attribute over here in the function name. Now, since I'm expecting all the data to be passed from the request body, I'm not taking the query string into the into consideration over here, or else you can also take the data from from the frame. Now I'm using out the body. Now I have a response message. It's like if I'm unable to process the whole thing, I'm going to send some message as an acknowledgement to the user. Like he should know whether the request went well, or it just flashes somewhere in the middle. Something the expected thing didn't happen. So you need to give a feedback. Suppose we run into any exception, I want to pass it in a response message. So that's why we have a variable response message over here. Now you can see the try catch block, just exceptional handling thing, nothing more. The feedback data. Here I'm deserializing the request body into a feedback object. Now I just had created an instance of a business class. We used to do it in the controller by accessing it through our interface. I'm just creating an instance of a business class to pass in the data, which we used to do in the business itself. I'm sending it from here to the submit feedback. Then after everything is done successfully, I'm giving thank you for the feedback. This is the acknowledgement that, yeah, okay, everything went well. I'm giving an okay result, which will give a 200 code status code back to the user. Okay. In any case, if it fails, I'm sending a bad request object result with an please try again later message. Okay. So let's see whether we get the out system or not. Let's run the function. Any doubts over here?
So Ashirwad, can you share after this session, can you please share this API and before and after you are migrating to function app? Can you share those solution?
Yeah, I'll definitely share it. I'll share the link with Paras. Maybe he'll be able to share it with you.
Sure.
Okay. We haven't changed much here. We just added an HTTP function over here, just like we had created previously for a HTTP trigger function. I just made some subtle changes. I'm not implementing an interface anywhere here because, as you can see, it is a static class. We can't do it. I'm creating the business is as it is, how it should be in a normal web API. In a normal project, how you declare your business layer? I'm just doing that. I just have it as a here. Just I'm calling it. I'm just passing my whole thing with that. It's as simple as that. Right. Okay. So I have given a debugger breakpoint over here. Let's see. We are testing it locally right now. When we publish it, even I'll share the endpoint with you people. You can test it yourself. Okay. The you saw the log thing over there. This logging information would be visible. But in Azure, you can turn your application sites, and you can just check it over there. And to store log information, we need a storage device, a storage account. This is the reason why we need a storage account with every Azure function that we make. Multiple function, Azure functions can share a single Azure, storage account, but at least you need one to work on because you have all these resources. You need to keep the, the logs of all the functions. You need some storage to store it somewhere, right? That's where the storage account comes into picture. Okay, as you can see, I said you that by default, the API name here should be the function name, but since I had changed it in the route over here to keep it as test demo, that's why we are getting the name as test demo. So let's test it in Postman. I'm going to Postman. Just let me know when we are all in Postman. We can make the test. Okay, all of us are on Postman. Do I need to wait?
Yes, we are in.
Okay, can somebody tell me your email address? I've been doing all this thing in my account, it's pretty confined. You can share me your email and you can test it live that the application works actually. Anybody is willing to share your email address?
Yes, it's. Can we chat over somewhere? Like, I don't find any chat option.
Okay, the chat option wasn't available for the session. Can you spell it out? I'll just type it. No?
Yeah, it's S for Sierra, A for Alpha, U
Sorry,
for
sorry. You can just spell it S
SAU
SAU
MYA
MYA
.114 @gmail.com.
.114 @gmail.com.
Yeah, that's correct.
Okay, great. So your name is Soumya, right? Soumya. Okay. Would you like to give a product or a bad product? Like, let's take it good. We have tested.
Yeah.
We have given a lot of bad reviews. So let's send the request. Simultaneously, we'll also do the testing. The debugging thing. Okay. All of us are on. All of us are there? Can somebody confirm? Like all of us are in the same screen?
We are the Visual Studio screen. Submit feedback.
Okay, great. Let's debug it. Okay, now the log.log information. I'm giving something log. So I told you that this log information will be visible in the core runtime tool. So as you can see in the core runtime tool over here, we got a message over here like C# has trigger function process a request. And this request was given by our Azure function, which we are dealing now locally. Everyone can see this, right? This particular message?
Not yet, not yet.
Okay, I'll wait.
Yeah, now we see it.
Okay, here you can also see all the information regarding that particular request that was made by us. Like it was a post request, this was the URL for the request that we are having, that's the request ID and everything else. Now we are inside.
Where is this actually logged? Is it a tool or what exactly is it?
This is a runtime tool actually. Whenever you install this Azure SDK, Cloud SDK, you'll get this bundle up with that. This is basically like the compiler for your Azure Functions. You can consider it more like that.
Okay.
Okay. So let's debug it. While we are debugging it, we'll see that the whole business flow was moreover similar to what it was there in the web API. Okay, all of us there in the same screen, right? In the Visual Studio. Still
Yeah.
Okay. Yeah. Okay, I'm debugging it. So now we are deserializing the body, into an type feedback. We can see it over here. All the details are there. Soumya.114@gmail.com. The feedback on the product, but this was a really good product. And the name is Soumya. We are instantiating a class of our business. And now we are going to go into the business and see the flow. So let's click F11 and go in there. Okay. Just let me know when we all of us are in the business. Okay, all are there in the business?
Yes.
Okay, great. Okay, let's go to the first part was to find out the sentiment of the the feedback, whether it was positive or negative. Depending on that, the whole workflow goes on. It depends. So let's step into the feedback analyzer class like we did earlier in our web API case. So we are there in the feedback analyzer class. I'm just waiting 5 more seconds to, for all of us to be on the same screen.
So this text analytics you are mentioning, what exactly is it? You're referring an endpoint there, right? Can you?
Yeah, actually, this is moreover like whenever you actually provision an cognitive resource, in cognitive API in Azure, you're given an endpoint and an API key to actually make a request. It's basically like we are making APIs here, right? Every API has an URL which acts as an endpoint. So the endpoint is basically the URL of that particular, what do you say, the text analytics server, which it has exposed us to use it to pass the data so that it can take it, process, and give it feedback and response. So
Okay.
it's the endpoint.
Okay, so you're using that. That's provided by Azure, is it? Text analytics.
Yeah. Actually, the internet issue is a bit here, so I am unable to show it in the Azure portal. Or else I would have showed you how to provision all these things. Then we were supposed to actually do this, but for the time being, I have skipped that. You can you can just provision a text analytics resource. You'll get all these details over there. You'll whenever you go to the endpoints over there, keys and endpoint, you'll get your key and your endpoint. You just need to put both of these things over there. Okay. So okay. So I'm passing my feedback over here. You can see it over here. This was a really good product. I'm making a request to the client, using the endpoint and the credential. It's using the credential to authenticate whether this is a valid request or not. So now let's make a request. As you can see, a request is being sent and it's analyzed, and we get back our response. And we can see the response over here. It gives a document sentiment type of a response. So I am storing in that particular class. So you don't need to define the document sentiment class. Actually, whenever you install azure.ai.textanalytics nugget package, it comes up, it bundles up everything and makes it available for you. You can see the count of the sentence is 1. You can see the sentiment type is positive. So now we're going to return it back. We're going to go back. So we are here in the business. Let's wait for 5 seconds. Okay, all of us there in the business?
Yes.
Okay, let's go to the email one. Now, our flow was basically whenever we get negative feedback, we need to send an acknowledgement to the client as well as to the management team regarding the feedback. This is the feedback. This was the negative feedback we got. You can have a look at that. So there's any other, position that you have over it. But right now we got a positive feedback. So our flow changes a bit. Now we are only giving an acknowledgement to the client. Like, thank you for your feedback. Why should we say we regret for your inconvenience? It doesn't make sense. And why should we send a positive feedback to the management team? Because it wasn't even a requirement. So all of us are in the send email part in the email class. Okay. Let's check. Okay, now we are in the else condition. So since our feedback was positive, you can check it over here. It's positive. So we go it down over here. We're going to send an email to Soumya right now. So an email is sent. Soumya should be getting an email in next 30 seconds to 1 minute. Okay. So since that is done, we are back in business. Now we'll insert the same record about Soumya in our DB, like whatever the details that Soumya gave us, we're going to do it. So instead of going to the Dell, we should go into the Dell. We have, other methods. Why should we skip this? So we are going into the Dell, the data access layer. You can see the whole thing is same. Nothing has changed. So migrating to an Azure function from a normal, web API is not a big change that you're going through. You don't need to rewrite your whole code. Just you need to change the way you write your controller part. You can see all of us there in the Dell, right?
Yes.
Okay. As you can see, the whole thing is same. I haven't changed anything over here. The whole code structure is changed. Even I've shared actually the same project. I haven't made any changes with this project. The only thing that I changed is that instead of calling it through the through an calling directly by creating an instance of the business class, and rest everything is the same. I'm having the same code. I'm using the same Azure.NET code. Nothing, nothing changed over here. I'm just using the SQL command to, execute the whole thing. I'm executing a non-query to insert it. If you see as a whole, if you know how to make an API or a way, how to make a web app using .NET, you can very well make Azure, web API using functions. Okay, now it is inserting the record in our DB. So it's sending a request. So yeah. So it did insert. Let's go back to the business. Actually, right now we don't have anything to go in the business, but still we'll check the feedback. So let's wait 5 more seconds in the feedback. In the meanwhile, Soumya, did you get a mail? Can you just check your inbox and see whether you got a mail with an acknowledgement?
No, Ashirwad, I haven't received any email.
Okay, let's wait. We're gonna check again. Let's wait for a while. It should come actually. Is the email correct? saumya.114@gmail.com.
Yeah, that's correct.
Okay, great. We'll just check into that. Sometime, the email bounces up, but we can check it in the SendGrid. What do we say? A SendGrid portal. If something didn't go, normally it should go in.
So are you
maximum
logging anything in here? Like once the email sent, are you logging anywhere in the application?
No, I'm not logging it in the application, but
Logging. I mean logging in.
No. I'm not logging anywhere. I'm just giving my email address to send it. I'm not providing any credentials over here. That's actually that's actually why I use SendGrid. I need not share any of my credentials. Okay. Are you saying something, Soumya?
Good.
Okay. Okay. So let's go back here. And let's just continue. There's nothing more. Even if we go and debug, we're just gonna see the response message like "Thank you for the feedback." We're assigning the response message as "Thank you to for the feedback." Then we are returning an OK result object. It's moreover similar to the 200 status code. Okay. All of us are in the same screen, right? Okay, I guess we are. So let's just click on continue and check in Postman what we got as a feedback. Just let me know when all of us are in the Postman.
Yes, we are.
Okay, as you can see, the response is 200, which is the status code which we were expecting for a successful, HTTP trigger execution. And it got the response which we wanted it to get. Thank you for the feedback. You can have a Ajax box, dialog box in which you can show this one whenever your request is done. So since we have already gone through how to actually execute, debug, all this stuff, let's publish it, because at the end of the day we need to publish our functions, right, for them to work. We just can't use it locally. We need others to use it too. So just let me know when all of us are in Visual Studio.
Yes, we are.
Okay, we are in the function apps screen. Let's right click on solution. Let's click on the MSFT reactor function where our function apps. Right click, publish. We're on publish screen. Let's to be on the same page. It's really simple deployed using Visual Studio. All of us can see the publish screen, right?
Yes.
Okay, great. Let's click on publish. There are other things I have mentioned, the connection of a DB inside the business, which typically we shouldn't do, we can configure it over here. We can make some changes in our settings and we can do it. But for the time being, I'm just gonna publish it directly. Okay, it's gonna connect with my Azure portal. It's gonna get all my credential from there while publishing it, and it's gonna show me all the function app which are available and in which function app I want to deploy the Azure function. So we have been talking a lot about Azure function, but we haven't discussed much about function app. So function app is basically a collection of all the Azure functions, you can say. Like we have controllers, and inside the controller, inside an API controller, we have multiple API methods. Similar to that, a function app consists of a lot of need not is not mandatory, like all the Azure function inside a function app should be HTTP triggered. They can be triggered by a change in the Cosmos DB, or else it can be a queue trigger or a timer trigger, or it's a blob trigger. Whenever something you upload something in your blob, then it Azure function fires. It can be any kind of Azure function. There are no restriction to that, but you can logically group every all these functions which give out a common purpose using a function app. Okay, it's taking a longer than usual time again. Okay, started. Okay, why did I start the build process directly? Okay, since I had published this thing beforehand, before doing it, I have this copy in my function app. That's why I directly published it over there, because it already had all the details where it needed to publish it. So let's do one.
I just have one clarification. So
yeah,
is Azure app something like an API proxy you're referring to? I'm not clear on the concept actually.
It's not a proxy. It's basically an API itself. Azure function offers you to write APIs which are triggered on an event, and post execution they would die out. They won't be staying there taking out your memory.
Okay, so
like whenever you
host your function app, I mean, how you're hosting it in Azure?
Okay, there are multiple ways you can host your function app. One is using the consumption model. It's basically the serverless way. You're only going to pay for every execution cycle you have. You have 1 million free executions. The second is using the app service plan. Like you have an app service plan in which you host your web API or your web apps. If you have one, you can host your Azure function in that particular API app service itself. You need not create something else. You need not have an app service plan separately dedicated for this function app. You can bundle it up with your existing app service plan. Okay, and it also gives you an advantage actually. Normally when you go on an consumption plan, there is a cold start. Like the first time your Azure function runs, it you go for an app service plan or else premium plan, you have already warmed instances. They are all already there, just to run whenever an request comes. So there is zero cold start involved when you're going for an app service plan and in premium plan. There's one more thing. It's more like some organization have hybrid cloud, multi-cloud approaches. Okay. Maybe because of the internet issue. Okay, I'll just show it in the portal. Okay, where was I? I was talking about the drawbacks. Actually, there are certain drawbacks involved with Azure function. It's the execution time. It's moreover like what we say. Your API should execute within 10 minutes if you're using a consumption plan. Because if it doesn't, complete by then, your function at 10 minutes, you get a log like white pale. But the maximum time limit that you have is 10 minutes with a consumption plan, which can be stretched a bit to 60 minutes if you're going with a premium plan. Though 60 minutes is guaranteed, the execution time can be unlimited, but that's a guaranteed time you get with the premium plan. But if you're hosting with the app service plan, you already have all these things there already for your dedicated storage, dedicated memory available there for you. You can run it for unlimited time. Your execution go for unlimited time. There is no timeout, at least there. Okay, now we are in the function app. Earlier we tried to create one, But after creating, this is how the function app window actually looks over here. This is basically my URL. So just like we had localhost colon 5151 or 8080/API/thing. So this is gonna be our what do we say, public address. So now we can see here in the functions, we have multiple function over. All of you can see the function app screen, right? In the browser.
So this function app service is provided free from Azure, right? We just need to add our Azure functions into it, correct?
Yes, it's absolutely free for 1 million execution cycles. But to actually use it, you need at least a subscription. You do not require any credits for that, but you at least need a subscription to actually get into the Azure portal.
Okay, yeah, I'm clear about that. But what I'm asking is, so this is like a interface where you can see all your function apps, right?
Yes,
Am I
yes,
correct?
yes, exactly.
Okay, okay.
Okay. So in this functions, when you click on this function, you can list all the APIs that are there. All the function Azure function that you have created. Since I have developed locally and published it, I cannot make any changes in this function app right now. I can only add Azure function in this particular function app via code, via the Visual Studio. I cannot add directly in the portal. But if I had created one using the portal, I could have added, as well as I could have, published a locally developed Azure functions. This is one constant. You cannot check the files over here, which I have uploaded, because it doesn't allows you to go through the business and everything that I've written in the code. It just gives you maybe the host.json, I guess. That's the only thing that should be visible over here. You can click on code plus test and you can see the screen. You won't get any of the codes available over here. Only the function of JSON, which actually, tells about, what we say. It's just like the metadata of our Azure function, like which kind of type it is. It's an HTTP trigger one, which method it entertains, whether it takes get, post, put, delete, what kind of methods actually can it accept. So you can see it's a post, it's an anonymous one, it's a request. Okay, you can also test your function here, though you cannot add one, but you can test it out here. You clicking on the test or run, giving your inputs over here, and check the response over in the output screen. You can get it out here. It's also a way to test it out. You can develop your Azure function in the portal and test it out here. You can also get the function URL. This is the public URL, which you can paste and test, or else I can use it in the SendGrid in the Postman to actually test. So this is basically my API's endpoint after I publish. Make sense?
Yes.
Okay. So I just wanted to share one more thing. Normally in APIs, what happens that we normally don't put everything inside a body or or in a query string, right? We just don't put everything out there. We can also have a placeholder like API / feedback /1 to fetch all the records that are available in which are having an ID 1. So you can also do those kind of things. So I just wanted to show that's the last thing that I'm going to share in today's session. So just let me know when all of us are in the Visual Studio.
Yes, we are.
Okay, so this was the first function that we made, the simple HTTP trigger. So I just wanted to show you how to pass a value in the placeholder in your URL and out and consume it in your function. So just like the way we change the route instead of getting back as our API name, we got test function, something like that. We can also do it here. Like I'm giving it placeholder / our ID. Let's click here, string ID. Now I'm gonna share it over here. Let's see how we can access it directly. It's very easy to access this. Okay, so this is the only change that you needed to make. You need to write the variable name inside the braces, then define a string, define that particular ID as a parameter in your HTTP trigger attribute. Next, you can directly access it over here. You can fetch it directly using the parameter name. So let's see if it works or not. I'm gonna run it again. You can make it also optional, you can make it mandatory, you can make it optional. All those things are available. Just like the way you had those flexibilities to, define the routing in your normal web application or your web API, you can also do the same with Azure Functions. Let's test it. We saw that the ID came in the braces over here in the core runtime tool. Let's go to the Postman and test it. All of us are in the Postman?
Yes.
Okay, as you can see, I had given, okay, let's check. Okay, it's placeholder, not function one. So it's placeholder. I'll just copy it, that's better. There shouldn't be any typo errors. Okay, so it's placeholder /1. This is the placeholder name. This is the value that I wanted to pass in the URL itself. I need to give an something in my body, or else it's gonna not display it. Else, yeah, we can debug it, but it's okay. Let's debug it. That would be better. Can just pass a name, raw text as JSON. Just keep a name as Ashirwad. Okay, let's send it. Okay, all of us are in the Visual Studio Code. Visual Studio, sorry, all of us there?
Yes.
Okay, let's debug it. Let's see whether we got the value or not. Okay, let's hover the cursor on the ID, and you can see we got the value that we passed in the placeholder. Right? We got the one. We passed one. We got one. Let's see whether we got the response or not. You can just continue because there isn't much to see over here. You can see hello Ashirwad and 1. 1 was the value which I passed it over here. Right? So this is how you can, work around with your routing, get the data through your routes, That's all from my end. Any more questions? We can have it.
I have a couple of questions, Ashirwad. Is Jitin here? You can
Sorry?
hear me, right? You can hear me, right?
Yeah, I can hear you.
Okay. The first question is, how do you handle throttling for this? If you have overwhelming requests, how do you handle it?
It's actually the thing is under the hood, there is a scaler that is there with Azure Function. It auto scales. You need not bother about those things.
Okay.
But the thing is, the only thing you need to bother about is cold start, because if your Azure Function, this function API doesn't run for a certain amount of time, like the timeout period is 5 times, that's the idle time. After that, what happens is that whenever you fire a new request, there would be a latency of 1 second. It's very low, but there would be some latency if you're going with the consumption plan. So this is one thing that you can be bothered about, because you don't need latency if you have a.
So how is the Azure Functions implemented under the hood? Means is it a container, or which it runs on, or is it a hosted service in a server? How does it run under the hood?
It's like a service in a way, you can say. It's just like an app service. What happens is that Azure has a lot of data centers, right? So they have a lot of servers which are not working at that particular time. So what happens is that whenever you publish a function, a particular storage has been allocated in one of the data center wherever it is available at the time. And once once your usage is complete, it would be deallocated from the server dynamically. Everything happens in a flash of a second. They have some scalers under the hood. You actually assigns the space for them, and post the execution, they are just what we say, flushed out.
Okay.
No being used after that. Okay. From there, when you said container, there's one thing that I want to say, which I skipped. Thank you. It's more like suppose your organization has works on 2 different cloud ecosystem, like they have AWS, they have Azure. So the thing is, you write your whole API using Azure Functions. Now you may be thinking, like, if I want to go to AWS in the future, I may have a vendor lock-in with Azure. The thing is, when you deploy your Azure function in a container, you can just take the container and host it in AWS in their app service plans, for whatever they call it there. You can just host your container and use it as you normally consume your web API when you host it in a container. So you can also avoid vendor lock-ins here if you're hosting it as a container using Kubernetes or Docker.
Okay, but if you're using containers, you can use Azure functions which can be deployed in container, or do we need to have another container service to deploy our?
No. The thing is, see, the function runtime tool is actually open source. You can download it, you can install it on your system. So it's more like you need to install that in your Kubernetes engine. You need to keep the whole setup just the way how you actually work with how you host your application inside a Kubernetes container. It's very similar to that.
Okay. So can we, to avoid this cold start? I mean, can we schedule any events, or is there any option in Azure to keep it like normally? How we do is we keep pinging the health checks. Like in AWS, you have Lambda. It has the same issue. It has a cold start. So there, what we do is we schedule an event which pings the health check like every minute to make it warm. So do you have anything similar in Azure?
See, you can create a function which anonymous function which can just hit all your function just to make sure that they didn't sleep. But also there's one more option. There's a premium hosting plan in which you can have pre-warmed instances. It's pretty similar with the consumption plan, but the thing is it's going to cost a bit more. But the thing is, all your instances would be pre-warmed. You wouldn't have any cold start.
Yeah. So your current Azure function is HTTP driven. Am I right?
Yes.
So can I create an event and make it event driven as well? Say suppose I'm creating an event which will call this Azure function at say every 1 minute. So can I trigger it the same Azure function using the event hub or service bus?
Yes, you can do that. It's absolutely possible. Okay. Even you can have a webhook, tied up with this Azure function. It's like every time, like the GitHub monitor, which is available. You can see the tutorial in the Microsoft Learn. It's like every time somebody commit something in your repository, you're gonna, get that information. You're gonna trigger your Azure function. I had one, which used to send me mails like whenever somebody committed in my repository. You can also do the same thing. You can bind up this particular API with your webhook to work around.
Okay, sure, Ashirwad. Thank you.
Okay. Any more?
How can we deploy Azure function to a container? Can you suggest on that?
Okay. You can actually make a container, and while creating a function app, actually you can choose it. At that particular time, you need to choose which runtime you're actually using it. So at that time, you can specify and publish it. While publishing, you can mention it. Maybe we can have it in a separate session sometime around, because it's actually a broader topic to discuss.
Okay.
Or else we can connect later and discuss about it.
Okay. Thank you.
Okay. Azure Function supports a lot of languages. It's not like you're bound with .NET. Yeah, you can make Azure Function using Java, Python, Node.js. Even you can do it in TypeScript. The same thing, Node.js, TypeScript, but still, even in PowerShell. Can you imagine writing Azure Function HTTP APIs using PowerShell? Who would have imagined it? But we can with Azure Function. Okay. Any more questions?
Can we deploy this Azure function in private cloud like PCF and all?
Sorry, so the last line I didn't get it. Can you say it again? Private cloud?
Like PCF.
Okay, private cloud with the premium option, actually you can, I guess, using there are some gateways available, some VPN gateways available here, so you can use that to do it. But I haven't actually worked on that, so I I cannot comment pretty confidently on this, but I guess you can. I think you can. May I know your name? We can connect later and discuss about it. I have never come across this particular problem statement, but I can just explore a bit and we can discuss about it.
Yeah, sure.
May I know your name?
My name is Soumya.
Okay, Soumya. We can connect later and discuss about this.
Sure.
Okay. Okay. Any more questions?
Also, it will be good if you can share your contact details, like your Twitter handle or any email.
Yeah, I have shared it actually in the beginning of the session. Okay, okay. This is my GitHub repo where you will find the solutions. I'll upload it by tonight. You can check it out there. This is my LinkedIn profile, and that's my Twitter handle.
Okay. Okay.
So this PPT and solution, everything will be uploaded in the GitHub repo, right?
Yeah, that will be available in the repo. One thing I can do is that I'll just share that in the comment section in the meetup page. I'll share it in the comment section. That would be helpful. What do you say, Paras? Would it be a good thing, or else you can pass it out to others?
Yeah, we can do that. Like that would be perfect.
Okay, great.
Thank you.
Okay, so that's all from my end. Thank you all, and stay safe.
All right. I guess
you,
that's
Ashir.
it. Thank you everyone for attending. Thank you, Ashirwad, for an amazing session. I hope to see you another section in another session. By that time, you guys can check out our meetup page for more such sessions. Recording of this session will be uploaded to our YouTube channel, so you can check that in a few days as well. And you can also find the Reactor Global sessions over there on the YouTube channel. All right. Thank you again, everyone. Thank you, Ashirwad.
Thank you, Vivek. Thank you, Paras, for giving an opportunity. It's such a wonderful platform to speak.
You're welcome.
Thank you. Have a good day.
Thank you.